record the session. All right, so we can start, I guess. Now, so let's do one more example about graphing polynomials. So this is still section 2.3. So it's about graphing polynomials.
So,
Yes. Yes.
The leading coefficient, is it the first number or is the largest number?
No, the leading coefficient is the coefficient in front of the highest power of x. So in general, it's the first number. So the number in front of the highest power of x.
Oh, okay.
Mm-hmm.
Professor,
So yeah. Mm-hmm.
so how about if the second term has the largest power of x, so that number would be the coefficient?
Yes, I mean if like let's say you have your highest power of x like in the second position, then yes, yeah, the number in front of your highest power of x would be the leading coefficient. Yes.
Right.
Mm-hmm. Yeah, absolutely. Yeah, guys. So we said, so here's the general steps to graph polynomials. So we said first we have to determine the behavior at infinity. Second, find the roots and their multiplicities. Right, and then we said we have to find the y-intercept. And finally, number 4, you're going to use all these informations to sketch the graph of f of x. Right. Okay, so I think we had 2 examples or 1 example, I'm not sure. But anyway, so let me show you with another example here how to graph this polynomial. So example, just to remind you how to determine the behavior at infinity, how to find the roots and multiplicities, etc., etc. So here's an example. So let's say you have f of x. Oops. So let's say you have your f of x equals to, so let's say you have minus, so just to probably to answer one of your questions, so minus 2x squared, and then you have plus x cubed, plus x cubed, all right, and then plus x. Okay, so first thing to do is to determine the behavior at infinity, right? So this is the first step 1, the behavior at infinity, right? So we have to find the degree. So the degree here, that's the highest power of x, right? So the highest power of x in this case, in our f of x is of course 3, right? That's the highest power of x. So the degree of f of x is 3. Okay, and that's odd, right? 3 is odd, of course. Now, what's the leading coefficient? So the leading coefficient is not -2. The leading coefficient is the number in front of x cubed, in front of the highest power of x. So here it's 1. Yeah, absolutely, Glenn. Yeah. So it's not -2, so it has to be +1. So the leading coefficient it's the +1. Right? And of course it's positive. All right. So once you know the degree, you know the sign of the leading coefficient, right? Then, so remember, guys, we had the table of behavior at infinity. So basically, we had like 4 cases. Here, degree even, degree odd, right? Here, leading coefficient positive, and here leading coefficient negative, right? So in our case, the degree is odd, right? It's 3, so it's odd. So we are in the second column. Now the leading coefficient is positive, so we are in the first row here, right? We are in this first row, right? So it's first row, second column. So our behavior and at infinity would be this. We are in this case here, right? And so that will be this behavior here. So the answer should be, so your graph is going to start from the bottom, from the left here, from the bottom down here, and going to go up right here, up here. Okay. So that's the answer. Again, I mean, this answer means, it means that when your x is at positive infinity, your y is also at positive infinity. And when your x is at negative infinity, your y, sorry, when your x is at negative infinity, your y is at negative infinity, right? Is there any question, guys, about the behavior at infinity? So we need to make sure, like in the test or in the final, you need to make sure that you have the table of this behavior at infinity in your formula sheet, all right? Okay, so let's see. Now next, so we have to find, so step 1, step 2 now, we have to find the roots. Right, and their multiplicities. So first, let's find the roots, right? So step 1. So step 1, first thing to do, find the roots. So we have to solve f of x, find the roots. So we have to solve. So how do we find the roots? Well, we have to solve f of x equal to 0, right? So we have to solve, my f of x is this negative 2x squared. So it's negative 2x squared plus the x cubed plus x, right, equal to 0. So how do we solve such an equation? Well, first, we cannot use a quadratic formula because the highest power here is not squared. The highest power is 3. It's a cube, right? So we cannot use a quadratic formula. Now, the next thing we can try is to factor. Try to factor. And how do we factor? Well, the question is there a common factor? Common factor, right? Well, is there a common factor? Yes. X is a common factor because there's an x in here, an x in here, and an x in here, right? So we can factor out x, right? So here the answer is yes. So factor out x. So here's my x. And so if you factor out x, then, here there's this negative 2. And here, factor out x, then you are left with x. So it's going to be negative 2x plus, then here's x cubed. So if you pull out x, then you are left with x squared, right? X times x squared, that will be x cubed. Then there's a plus, here's my plus, plus x. So if you pull out x, you are left with 1. It's not just 0 because this is supposed to be 1 times x, right? So it's plus 1 here. It's not plus 0, right? You are left with 1. E equals to 0, right? So now, so why do we factor? Because when you factor, you're going to have a product. So this is a product because it's a multiplication, right? This is a product. and you have a product which is equal to 0. So whenever you have a product equal to 0, then you can say either the first number is 0 or the second number is 0. So either my x is 0, right? This is my first factor is 0, or my second factor is 0, or minus 2x plus x squared plus 1 equal to 0. All right. So x equal to 0, I got my first root. So x equal to 0, that's my first root. Now we have to solve minus 2x plus x squared plus 1. I mean, this is just, sorry, this is just a quadratic equation, right? I can, so if you start with x squared minus 2x plus 1, so this is just a quadratic equation, and I can use a quadratic formula, right? So it's just, so the solution is going to be x negative or minus minus b, so minus negative 2 plus or minus square root of b squared, that's 4, minus 4 times a, 1 times c, 1 over 2a, 2 times 1, right? So then your x, it's minus negative 2, that's positive 2, plus or minus 4 minus 4, that's 0, square root of 0 is just 0, right, over 2. So it's just positive 2 over positive 2, so it's equal to 1. So my second root is actually positive 1. All right, so I got, we have two roots. So we have two roots, x equal to 0 and x equal to 1. Right, so now, okay, so I got my roots. So remember, guys, we have to find the roots, we said, in the multiplicities, right? So first we said we have to find the roots. Next, we're gonna find the multiplicities. So step 2, I'm gonna find, so step 2, I'm gonna find the multiplicities of the roots. And how do we find the multiplicities of the roots? Well, we have to factor completely f of x. Factor completely f of x. Okay, so your f of x was, our f of x was, oops, our f of x was, x cubed, where is it? Yeah, it's x cubed minus 2x squared plus x. So it's x cubed. I'm going to start with x cubed instead of x squared. So x cubed minus 2x squared plus x. All right, so we said we can factor out x. So it's x squared minus 2x plus 1, right? Now, first factor, it's x, right? And there's nothing else we can do here. It's just x, right? Times x squared minus 2x plus 1. So this one is actually a quadratic function, right? So we can factor, again, this one here. So we have to factor this, right? Because it's a square, okay? So you can try to factor this quadratic function, right? So then, yes, Kwame, it's x minus 1 times x minus 1. So that's equal to x times, so if you factor this, it's going to be x minus, so it's supposed to be x minus the first solution of, so this is supposed to be x minus the first solution of x squared minus 2x plus 1 equal to 0. But 1 is actually a repeated solution. It's a 2 times solution, right? So here times x minus 1, and this is supposed to be x minus the second solution, x minus second solution of x squared minus 2x plus 1 equal to 0. But I mean, when we solved x squared minus 2x plus 1, we got only one solution, which is 1, right? So 1 is a repeated solution. Yeah, so anyway, so it's x minus 1 times x minus 1. So then that will be equal to x times x minus 1 squared. All right, so now we can answer. So so we can answer the question. So we have 2 roots, x equal to 0, and it's actually of multiplicity of multiplicity 1 because that's the power of x minus 0. That's the power of x minus 0. That's the power of x minus 0, which is x. Okay. Now, what about the multiplicity of 1? Sorry, it's of multiplicity 1 here. Oops. So of multiplicity 1 here, right? Now, the second root is 1, so x is equal to 1 is of multiplicity 2 because multiplicity 2 because that's the power of x minus 2 because that's the power of x minus 1. Right? Now, okay, so now we got our roots, we got our multiplicities. Next, let's check the steps. Well, step 3, we have to find the y-intercept, and then we can sketch the graph of f of x. So let's find the y-intercept. So 3. Find the y-intercept. Y-intercept, that will be solution, or you have to solve or evaluate f of 0. So just evaluate f of 0. So that will be 0 cubed, I think minus 2 times 0 squared plus 0. So everything is 0, so it's going to be just 0. So f of 0 is 0. So the y-intercept is 0, 0. Okay, the first 0 here, this is always 0 in the y-intercept. X is always 0. X always 0. Okay, always 0. But then the second 0, it's because we got 0 as answer here. I mean, our answer is 0, so that's why we have 0 here, right? So, I mean, anyway, but 0 is also our root, right? So now I can sketch the graph of f of x. 4. So I'm going to sketch the graph. Right. So, well, first, I have my behavior at infinity, the behavior of f of x at infinity, right? So it's supposed to start from the bottom here, down here, okay? And then the graph is gonna be at positive infinity right here, right? That's our the behavior of f of x at the infinity, right? And then we have to plot the roots. So plot the roots. So the roots, we said we have x is equal to 0 and x equal to positive 1, right? So I'm gonna need positive 1 here. This is my 0. So I'm gonna plot the roots. So here's 0 and here's positive 1. Okay. Now I'm gonna plot the y-intercept, but plot the y-intercept, but the y-intercept is just the origin, right? It's my root 0. It's the same as my root, right? So it's just 0, 0. So it's the same as my root. Now, so we need to keep in mind that, you know, x equal to 0 x equal to 0 of multiplicity 1, multiplicity 1. Okay, so that's odd, right? And x equal to 1 is of multiplicity 2, okay, which is even, right? Okay, now let's connect the point. Connect the point. So here I'm gonna start down here. So next point is gonna be my x equal to 0. Now, so what I'm gonna do when I touch the x equal to 0, it's of multiplicity 1, which is odd, right? So if it's odd, we have to cross the x-axis. Okay, so here I'm gonna cross the x-axis. Right, so once you cross the x-axis, of course, then you have to join the next point, the next root, which is 1. But now, what happens at x equal to 1? Because, so the multiplicity is even, right? So you're gonna touch the x-axis, just touch the x-axis and then turn around. All right, so he's gonna touch the x-axis, and I'm gonna touch the x-axis at x equals 1, and then I'm gonna turn around. All right, so that will be the graph of f of x. Any question, guys, about the graph? How I got the graph of f of x? Let me see the chat. Okay, no questions. Very good. So here's an exercise. So I'm gonna give you time, more time than the last time. Last week, because I think last week we had to rush at the end. So here's an exercise. So let's say f of x is, let's see. So it's x cubed. Okay, so it's, let's say it's x, yeah, so let's say it's x cubed minus 4x squared minus x plus 4, right? So please, guys, so find, first determine the behavior at infinity. Second, find the roots and their multiplicities. Right. 3, find the y-intercept. 4, sketch the graph of f of x. All right. Okay, guys, so we have, let's say, 5-10 minutes to think about this exercise. Okay, so please try to sketch the graph of f of x. So be careful, guys, here when you find the roots. I mean, you want to factor f of x, right? So first, there is no common factor here because you have 4 plus 4 at the end, right? You have plus 4 here, right? So plus 4 here. So there is no x in 4, right? So there is no common factor. So, and if there's no common factor, so then you need to try to do partial factoring. Okay. So any guess for the roots multiplicity, guys? Kwame, you said 0, 1, and 3. So it's not, actually, it's not correct. I mean, 1 is correct. X equals 1, it's correct. But 0 and 3, they are not correct. So any guess for the roots, guys? No, Kwame, I don't think it's correct. I mean, 0 and 3, they are not 0 and 3, they are not correct. All right, guys. So for number 1, so how do we determine the behavior at infinity? So well, so my f of x. So my f of x, of course, it's x cubed minus 4x squared minus x plus 4, right? So the degree, so this is the same as previous example. I mean, so the degree, the highest power of x is 3, right? So degree is equal to 3, and that's odd, right? And the leading coefficient, that's the number here in front of x cubed. So it's equal to 1. That's positive 1, right? So the leading coefficient is positive, is equal to positive 1. So it's positive, right? So we have the same behavior at infinity as the previous example. So the answer would be just, so the answer would be, so you start down here, and at positive infinity, your graph is going to be right here. All right, so this is the same behavior as the previous, as our example. Okay, next, now the number 2. So we have to find the roots and the multiplicities, right? So number 2. So we start with the roots. So step 1. So step 1, find the roots. So we have to solve f of x equal to 0. X equal to 0. So we have to solve x cubed minus 4x squared minus x plus 4 is equal to 0. Right? So we cannot use the quadratic formula. Okay. So now next we have to try, to factor f of x. So try to factor. And so the question is there a common factor? Is there a common factor? Well, as you can see here, there's no common factor because, as I said, there's an x in here, x in here, x in here, but there's no x here, right? At 4, it's just 4 by itself, so there's no x there. So there's no common factor, actually. So if the factorization doesn't work, so we can try partial factoring. Absolutely, Leah, yeah. So partial factoring. Okay, so what we can do is try to take, for example, the first 2 terms. So we have this x cubed minus 4x squared minus x plus 4 equal to 0. So I can take the first 2 terms here, right? So if you take the first 2 terms, then yes, then there will be a common factor. So common factor here, common factor would be not just x, but x squared. Right? So I can factor out x squared. So there'll be x squared times x minus, there's a minus, of course, minus, and then 4. If you pull out x squared, then you are left with 4, right? And now here, minus x plus 4. Well, Leah, the thing is, if you use the other x, then you won't get a common factor later, because well, you can use the minus x, but then you won't have a common factor later. Okay, so yeah, so yeah, so what I'm saying here, so if you take, of course, if you take these 2 terms here, then you can well, if you pull out the minus sign, so you're going to have minus, and here I'm going to have x minus 4. So then you see here, you would have this x minus 4 common factor. But if you use the other x, so here's just a remark, this is just a remark, if you use the other x, then remark, well, you can put x, so you're going to have like x squared minus 4x minus 1, and then there's plus 4, right, equal to 0. Okay, so then you won't have a common factor. Okay, so then there is nothing you can do here. There's no common factor. Right? So that's the difference with this situation here, where we got the x minus 4 as a common factor. So that will be here. That will be a common factor. All right. Yeah, anyway, so so then once we have the x minus 4, then we can so then we can factor out the x minus 4 times, here's an x squared, so here's my x squared, there's a minus, so it's minus, so here's a minus, and then of course this is this is 1 times x minus 4. So if you plug this x minus 4, then you're left with 1. So here it's x minus 1 equal to 0. So I got my factorization then. So it's a product. That's really important. So it's a product equal to 0. So then x minus 4 is 0. Or the x squared minus 1 is 0. All right, so x minus 4 is 0. So x is positive 4. And that will be my first root. So x is equal to 4, my first root. And then we have to solve the next equation, which is x squared minus 1 equal to 0. So we're going to add plus 1 both sides. So then x squared is equal to positive 1. Apply square root. Because the power is even, then you're going to need plus or minus. Right? So then x is positive 1 or x is negative 1. Right? So I got positive 1 and negative 1. Right? So we have 3 roots actually: positive 1, negative 1, and positive 4. So we have 3 roots: x positive 4, x positive 1, and x negative 1. Right? X negative 1. So this is the first step. Remember, guys, we want to find the roots and their multiplicities, right? So first, we said we have to find the roots by solving f of x equal to 0. Now, second step, we have to find the multiplicities now, right? So now we're going to find step 2, find the multiplicities. So how do you find the multiplicities? We have to factor completely f of x. Factor completely f of x. So what do I mean by factor completely f of x? So let me write down again f of x. It's x cubed minus 4x squared minus x plus 4. Right? So we said we had so when you do this partial factoring, so we have x minus 4 times x squared minus 1. All right. So we have x minus 4. That will be our first factor. This is our first factor. So there's nothing else we can do here for x minus 4. Now, what about the x squared minus 1? Because it's a square, okay, then you can actually try to factor this. So we have to factor this. Okay, so x squared minus 1. So if you want to factor actually x squared minus 1, it should be of the form x minus first solution of x squared minus 1 equal to 0, right? Right, times x minus the second solution. Solution again, we are talking about solution of x squared minus 1 equal to 0. All right, so I have my x minus 4. Here's my x minus 4 times, and then it said x minus first solution of x squared minus 1 equal to 0. So first solution was positive 1, so it's x minus positive 1 times x minus the second solution of x squared minus 1 equal to 0, which is negative 1. So x minus negative 1. This is minus negative 1, right? So, so factorization would be x minus 4 times x minus 1 times actually x plus 1. right, so I got my factorization, so now I can answer the question. So find answer here. So we have 3 roots, x equal to positive 4 is, and it's actually of multiplicity. It's of multiplicity 1 because here it's x minus 4 to the power 1, right? So multiplicity 1 because that's the power of x minus 4. Next root, it's x positive 1, and that's of multiplicity. So what's the power of x minus 1? Well, power of x minus 1 is 1, of course, here. Glenn, absolutely. So it's also multiplicity 1. That's the power of x minus 1. And finally, last root is negative 1. Negative 1 and is of multiplicity. So what's the power of x minus negative 1? So that's the power of x plus 1, right? So here I have x minus negative 1, so that's x plus 1. So that's the power 1 here. So that's power 1. That's the power of x minus negative 1, which is, of course, x plus 1. All right, so I got my multiplicities. All right. Any question, guys? Please don't be shy to ask questions, all right? Now, third step, step 3, we said we have to find the y-intercept. Find the y-intercept. So how do we find the y-intercept? Well, we have to evaluate f of 0. Evaluate f of 0. So that's f of x was, if I remember correctly, was x cubed. So we have 0 cubed minus 4x squared. So it's 4 times 0 squared minus x, so minus 0. And then we have plus 4. So f of 0 is positive 4. So the answer, the y-intercept, is 0, 4. Right? So because the answer, you see here, the answer is 4. So we got 4 here in the y coordinate, and the x coordinate is always 0 in the y-intercept. So this is always 0. Always 0 in the y-intercept. All right. Okay, so I got now everything I need to sketch the graph of f of x. So so now I can sketch the graph. Okay, so so here's my x-axis, y-axis. So first, what's the behavior at infinity? So we said the graph is gonna start from down here, right? And then at positive infinity is gonna be somewhere here, right? That's our behavior at the behavior of f of x at infinity. Now I'm gonna plot the roots. Remember we had 4, we had positive 1, and we have negative 1, right? So this is negative 1, positive 1, 2, 3, 4. One, 2, 3, and 4. So this is 4 here. This is positive 1. So I got negative 1. That's my first root. I got +1, second root, and third root is +4. Okay. Now I need my y-intercept. I need to plot my y-intercept. Plot the y-intercept. So the y-intercept was 0, 4, right? 0, 4. So I'm gonna need 0. So 1, 2, 3, and 4. So here's 4. So here is my y-intercept. Okay. So I have my roots. I have my y-intercept. It's 0, 4. So now I can graph my sketch the graph of f of x. So you start from down here. You have to connect to join the first root, which is -1. Now, what happens when you when you arrive at -1? So that depends on the multiplicity of -1. So -1 is of multiplicity 1, which is odd. So here the multiplicity is odd. Right? The multiplicity is 1, right? So it's odd. So when the multiplicity is odd, so you just cross the x-axis. So here I'm gonna just cross the x-axis. So next point I have to join is the y-intercept is the 4. Then I'm gonna go to the next root, which is +1. Now what happens? +1. So it's the multiplicity is again odd. Multiplicity is odd. Okay. And again, when the multiplicity is odd, then you just cross the x-axis. So I'm going to just cross the x-axis. Remember, if the multiplicity is even, then you touch the x-axis and you turn around. So I'm going to cross. Now next point is, or next root is 4. And 4 is also from multiplicity 1, which is odd. So I'm going to just cross the x-axis and join my infinity. All right, so that's the graph of f of x, or the shape of the graph of f of x. So any question, guys? That is odd, so we just cross the x-axis. Any question, guys? All right, so then we are done with this section 2.3. I guess we can move now to the next section, section 2.4. So in the section 2.4, guys, we're gonna divide polynomials. So we're gonna see how to divide polynomials, and we're gonna use division of polynomials actually to factor, to factor completely polynomials, because sometimes you can find a common factor. So if you don't find a common factor, you can try partial factoring, but sometimes partial factoring doesn't work. Okay, so we're gonna see a third way to factor polynomials, right? So I guess I'm gonna move to the next new page. So this is now this is section 2.4. And we said it's about dividing polynomials. Okay. Well, before polynomials, so when you divide numbers, guys, for example, let's say you divide 19 by, let's say by 5, right? So 19, when you divide 19 by 5, 19 is called dividend, right? And 5 is called divisor, right? Now, when you divide 19 by 5, you get 3, and you are left with 4, right? So 19, it's actually equal to 5 times 3 plus 4. So your 5 is the divisor. 5 times 3, that's 15 plus 4. So that's your divisor. The 3 is the quotient. and we are left with 4. So the 4, of course, is called the remainder. All right. Now we're gonna do the same thing for polynomials. So we're gonna divide polynomials. So we're gonna do what we call synthetic division. So we're gonna do, so the goal. So we're gonna divide. So we're gonna divide now polynomials. And we're gonna start by dividing polynomials by divide polynomials by x minus c. Yeah, so it's like long division, Kwame. Yeah, yeah, absolutely. Yeah. So we're gonna start by dividing polynomials by x minus c. Okay, so this is x minus c. Let me show you with the 1 or 2 examples how we divide polynomials by x minus a number. All right, so example 1. So we're gonna have 2 or 3 examples, guys, because just so we can understand how it works, right? So examples. So first, let's say you want to divide x squared, let's say, or 3x squared minus 7x plus 20 by x minus 3. Right? So x minus 3, so we're going to divide 3x squared minus 7x plus 20. So that will be my dividend. So this 3x squared minus 7x plus 20. That's my dividend. Right? And I'm going to divide it by x minus 3. So that's my divisor. X minus 3 is my divisor. So what we see, again, we're dividing by x minus c, right? So this is supposed to be of the form x minus c. So my c would be positive 3. So c is positive 3, right? C is always the opposite of this number. You have minus, then c would be positive 3. Okay. So how do we do the division? Well, so I'm going to make a table. So I'm going to have a table with the 3 rows. And, well, basically, so 3 rows. The first row, first column. In the first row, first column, I'm going to put C. So I'm going to put C here. In the first row, first column. So like here in my example, we said the C is positive 3, right? Because we are divided by x minus 3. So 3 is positive 3. C is positive 3. So here's my positive 3. Right? Yes.
Can you repeat why is positive 3? Because it's negative in there.
Yeah, that's what I was saying. So the form of the division we're gonna learn is so we divide by x minus c. So if you have x minus 3, then your c is the opposite. So if you have minus 3, then the c would be positive 3. I mean, that's the way how we divide. So if you have minus 3, then you have to put in the table, you have to put the opposite. You have to put positive 3. All right. Let's say in the next example, we're going to divide by x plus 2. Then in the table, you have to put the opposite. You have to put negative 2. All right. So in the table, we always put the number which is the opposite of this one here. If you have minus 3, then you put the opposite. That will be positive 3. Right. And then next column, we're going to put the dividend here. So next column here, we're going to put the dividend, right? So your dividend here, it starts with x squared. So here I'm going to put x squared. After x squared, I have x. And after x, I have a constant. Right? My dividend, we have x squared, we have x, and we have a constant. So how many x squared in the dividend? We have 3x squared. How many x's? We have minus 7x. And the constant is 20. All right. Now, the last row, guys, in the last row, we're going to have, in the bottom, in the last row, we're going to have the quotient. So here, so last, actually, in the, so in the last row, last column here, this would be always the remainder. Right? And here, we're going to have our quotient. But this quotient is going to be always 1 degree less than the dividend. Okay, always 1 degree. Always 1 degree less than the dividend. So you see, guys, my dividend, we started with x squared, right? Now here for the quotient, we're going to have x. We're going to start with x power 1 because it's 1 degree less. It's 1, you have to subtract 1 from the power. So here it's x squared. So this is x squared. So I'm going to put x power 1 here. Next, after x power 1, of course, or x, that will be a constant here. All right. Now, so how this table works now? Well, first thing is you bring down the first number. This one here, you always bring down the first number here. You bring down this number here, always. Okay, so you have 3 here, so I'm gonna put 3 here, all right? Now, next thing, so we're gonna multiply the last row by the C. So we're gonna multiply this, the C, the positive 3 by the last row. So it's like here we have 3 times 3, that would be 9, right? So I'm gonna put 9 in the next column. So here I'm gonna put 3 times 3, that would be 9. Now, what we do is for the column, next column, we add. So we have to add numbers here. So here we're gonna have plus, here we're gonna have plus, right? So it's like -7 plus 9. That will be positive 2. So we're gonna have positive 2 here. Okay. And then next, again, we multiply. So we have to multiply the last row by the number C. So this 3 here times this positive 2. That would be positive 6, right? So next column, we're gonna have 3 times positive 2. That's 6. That's equal to 6, right? And then we're gonna add, so this 20 here to the 6. 20 plus 6, that's 26. So we're gonna have here 26. Okay. So then, so how do we read the answer here? So the remainder, we said that would be the 26. That's the last row, last column. That's our, this number here. This is the remainder, right? So remainder is 26. Okay, now what about the quotient? So the quotient, we said, we start with x here, x power 1. So how many x power 1 we have? We have 3. So it's 3x plus, then the constant, it's plus 2. So it's 3x plus 2. Right? So remember, guys, in general, it's when you divide, so we have division. So we have the dividend. So the dividend, we said, dividend is this 3x squared minus 7x plus 20. All right, so we have, so 3x squared minus 7x plus 20. All right, so that's our dividend here. That's equal to the divisor. We divided by x minus 3. So here's my divisor. times the quotient, which turns out to be 3x plus 2. That's my quotient, plus the remainder, which is 26. So this is my quotient. And this is, of course, this is just the remainder. All right. Okay, so let me do one more examples, guys, okay? Because I know this is the first time.
So wait, that will be the
Yes.
final answer?
Yeah, that would be fine answer, yes.
All right.
So it's like saying 19 is equal to 5 times 3 plus 4, right? Yeah, so that'll be fine answer, yeah. Okay, well, so let me do one more example or two more examples. And then I will give you an exercise, right? So,
Can you wait a minute?
excuse me? Yes?
Can you wait a minute, please?
Yeah, sure. Okay, so example number 2. So let's say now I'm gonna divide 2x to the 5th is 2 minus x cubed plus 2x minus 1, right, by x plus 2. All right. So first, what will be my c? So if you want to divide 2x5 minus x cubed plus 2x minus 1 by x plus 2, so this x plus 2 is supposed to be of the form x minus c. So this is x minus c. So my c would be the opposite of this number here. This is positive 2. So my c would be negative 2. Right. So in the first column, first row, we're gonna put the c, which is the negative 2. So I'm gonna put so here's my table. Again, we're gonna have 3 rows. All right. So first row, first column, that will be c. So we're gonna put c here. So that's the negative 2. All right. Now the second. So the second column, we're gonna put the dividend. Okay. So what's the highest power of the dividend? So it starts with x to the power x power 5, right? X fifth, right? So we have x power 5. Then after x power 5, we're supposed to have x power 4, x cubed, x squared, x, and then constant. Right. Now, so how many x power 5 you have? We have 2 x power 5. So here I'm gonna put 2. How many x fourth? Well, there's no x power 4, right? So we're gonna put 0. So if you don't have some power, guys, you have to put 0. You don't skip the power. So I don't have x power 4, so I have to put 0. Okay, so don't skip if there is a power missing, don't skip it. You have to put 0. Right? So be careful here. Okay. Now x cubed. Well, it's minus 1. I mean minus x cubed. So it's gonna be negative 1 x cubed, right? X squared. There's no x squared, so we're gonna put 0. Is there an x? Yes, we have actually 2 x's, right? Plus 2x. So it's 2 x's, 2x. And then what about the constant at the end? It's negative 1. Right? Now, we said first thing, we bring down the first number here. This one here, we bring it down right here. Right? So that's 2. It's always the same number. Right? Then we'll multiply. We have to multiply by c now. The last row, we have to multiply. So here we'll multiply by c. So it's 2 times -2. That would be -4. So next column, I'm gonna put -4. Right? And then in the columns, guys, we have to add. So here, we're gonna have a plus, 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 right? So what I'm saying is, so this 0 here plus this -4, that will be, so there's a plus here, right? This is a plus. So 0 plus -4, that's -4. So in the last row, I'm gonna put the -4. Well, I'm gonna multiply again by my C. Remember, we have to multiply the last row by C. So it's -2 times -4, that's +8. So next column, I'm gonna put +8. And then I'm gonna add. So this -1 here to the +8, that will be +7. So here, I'm gonna have positive, this will be +7. Next, we're gonna multiply again by the C. Remember, here you have to multiply by the C. Yes, yes, Glenn. How I got the 7? It's because I just, you see this in the third, this column here, I have -1 plus, this is plus, right? So it's always plus. You have to add the columns here. So it's -1 plus 8. That's why I got the +7. It's like here, 0 plus -4, I got -4. -1 plus 8, I got 7. Now I have to multiply the 7 by the -2, right? We always multiply the last row by the C, right? So 7 times -2, that will be -14. So I'm gonna put -14 in the next column. And then I'm gonna add, right? I have 0 here, and I have -4, so 0 plus -4, that's -14. So 0 plus -14, that's -14 here. Okay. Next, I'm gonna multiply again by the C. So -2 times -14, that will be +28. So next column, I'm gonna put +28. And then I'm gonna add this 2 here to the 28. So 2 plus 28, that will be 30. So here, I'm gonna put 30. Well, I know, Kwame, it's a lot, but yeah, that's the way we do it. That's what we call the synthetic division, yeah. The 2 plus 28, that will be the 30. We'll multiply again by the -2. 30 times -2, that will be -60. So here it's -60. And then finally, we're almost done. So we have this -1 plus this. This is a plus, of course. So -1 plus the -60, that will be a -61. So here it's -61. Yeah, because I picked the power here is 5. So we have like a lot of columns. Yeah, but anyway, so now how do we read the answer? Well, the last row, last column, that's my remainder. So this is my remainder here, right? Now, what about the quotient? Well, here it's x power 5. So we said here in the bottom, in the last row, the quotient starts with 1 degree less than the dividend, right? If you have x power 5, so here you start with x power 4. So this is x power 4 here, right? So this is always 1 degree less. So x fourth, here after x fourth, of course, we have x cubed, and then x squared, then x, and then of course constant. Right? So what's the so what will be the quotient then? So then the quotient, it's x fourth, 2x fourth, x cubed, we have -4, so minus 4x cubed plus 7x squared minus 14x, and then there is a constant by itself, the 30 by itself, so it's plus 30, plus the 30. right? And
So I got a question.
yes,
So the zero, where do you get that from? The zero, like on the top.
yeah, 0. It's because you know, so because the dividend, you see here, this is it starts with x 2x power 5, right? This is here. This is x power 5, right? So after a power 5, we are supposed to have power 4, but there
Yeah.
is no power 4, right?
Yeah.
So you have to put 0. That's
Oh.
why I have 0 there,
Oh.
because you see here, there's no x power 4 there.
Yeah.
Okay.
Oh.
And the same for x squared. For example, here there's no x squared, so that's why I had to put 0 for x squared, right? I got this 0 here, and I got also this 0 here for x squared because there's no x squared. So you cannot skip. I mean, you have to put all the powers here. Even if there's no x squared or there's no x fourth, you have to put 0. Okay. And
Professor, can you move it a little bit to the right?
to the right. Okay.
Oh,
right,
plus
right,
30.
right.
Okay, what do we do with the remainder?
No, the 30, that's not the remainder. That's the constant, the plus
Yeah,
30.
I know, but what I'm saying is, what do we do with the remainder?
Nothing. So that'll be the remainder, right? That's the answer. That's just so in your answer, in your final answer, so the remainder here, that will be the negative 61, right? And so when you write final answer, so you're gonna write the dividend, which is the 2x fifth minus x cubed plus 2x minus 1, right? This is dividend equal to, so we have the divisor, we divided by x plus 2, right? We divide by x plus 2, so x plus 2. So here's my x plus 2, then times the quotient, which is at 2x fourth minus 4x cubed minus 7x squared minus 14x plus 30, right? And then I can close the parentheses and then plus what's left. So we are left with negative 61, right? So it's plus negative 61. Negative 61. Right, so yeah, so this is the divisor. This is the quotient. And we are left with negative 61. So that's our remainder. Right. One more example, Kwame? Yeah, sure, I can. Yeah, sure, I can do that. Yeah. Okay, sure. Yeah, I can do that. Sure. All right. Okay, so let's do last example, and then I'm gonna give you exercise so you can practice, guys. Okay, so last example, example 3. Example 3. Right. So let's pick a short polynomial. Okay, so let's say f of x. Let's divide. Let's say you want to divide x cubed minus 1 by, let's say, x plus 2, or x plus 1. Let's say x plus 1. All right. So if you say x plus 1, then your c should be the opposite. So this is plus 1, so your c is negative 1. All right. So when you make your table, so here's my table. So I'm gonna put the c. which is -1. So here's my -1. And then I'm going to have my dividend. So the highest power here is 3, right? It's x cubed minus 1. So we start with x cubed. And you don't skip the power. So after x cubed, you're supposed to have x squared. After x squared, you're supposed to have x. After x, you're supposed to have constant. All right. Now, how many x cubed? We have 1x cubed, right? This is 1x cubed. There's no x squared, so it's 0. There's no x, so it's 0. And then a constant, so we have -1 by itself, so the constant is -1. Right? Now, so what do we do? Bring down this. It's always the same number. So that's +1. And then here, we'll multiply the last row by the c. So we'll multiply the last row by the c. And then we're going to have a plus. Here's a plus, here's a plus, here's a plus. So multiply 1 by -1. That will be -1. So I'm going to put -1 in the next column, right? And then I have this 0 plus this -1. Right? This is 0 plus -1. So it's going to be -1. So here's my -1. Right? Multiply again by c. -1 times -1, that will be +1. So next column, I'm going to put +1. And I'm going to add this 0 here to this +1. Of course, that will be just +1 again. So it's +1. Multiply by -1. That will be -1. So we're going to have -1 in the next column. And then here, so it's -1 plus -1. Right? So it's this is a plus, right? Here we have a plus. -1 plus -1, that will be -2. So next last row, last column, that will be -2. And okay. So now, what will be then the answer? Well, last number here again. This is our remainder. All right. Now for the quotient, this is x cubed. Then in the quotient, we start with 1 degree less. So it's supposed to be x squared. After x squared, we're supposed to have x. And after x, we're supposed to have constant. All right. And so this would be our quotient. Okay. So the remainder is -2. And the quotient, of course, so how many x squares? We have 1x squared, 1x squared. How many x's? -1x. And what about the constant? Well, we have +1. So the quotient is actually x squared minus x plus 1. Okay, so then your final answer should be of this form. So answer. So my dividend was x cubed minus 1. We divided it by x plus 1. So my divisor is x plus 1. Divisor times the quotient, the x squared minus x plus 1. That's my quotient. And we are left with, of course, -2. So plus the -2. So this is my remainder. All right. Any question, guys? So then here's an exercise. I'm gonna give you a couple of polynomials to divide so you can practice. So exercise. Okay, so please divide 2x cubed minus 2x squared plus 1 by x plus 2, right? And then divide, let's say, 4x fourth minus x squared plus 2 by x minus 2. All right. Okay, guys. So let's say you have 10 minutes to divide those polynomials, right? All right, guys. I mean, we have like 4 minutes, so I guess probably I will come back to this next time. I mean, anyway, we didn't finish the section, so I have to come back to this section next time on Wednesday. But in the last 3 minutes, let me just probably solve number one. Um, um, I don't know if you have any guess for number one. So what will be the answer? What will be the quotient for number one? Any guess?
The question for number one will be
Mm-hmm.
2x squared minus
Mhm.
2x plus 4.
Yeah, yes, I think it's correct. Yes, absolutely. Yeah,
It's gonna be negative 7.
Mm-hmm. Yeah, I think it's correct. Yeah, very good. Yeah, absolutely. So, yeah, so for number one, because we are dividing by x plus 2, so then your c must be the opposite, right? So it must be negative 2. So when you make your table, so you're gonna have, sorry. So you're gonna have, negative 2 here. That's your c, and then
Wait, hold on.
for,
Did he say?
yeah.
Wait, not to interrupt. You said whoever just spoke. You said 2x² minus 4x.
No, he said, I think, no, he said minus x plus 4. I, I think so.
I
But
had
I'm
got.
gonna,
Yeah, I didn't get 4. I got 2.
okay, well, let's see then. So yeah, for the dividend, we have 2x cubed. So this is 2x cubed, and then for x squared, we have negative 2. For x, there's no x, so you have to put 0 under x, and then the constant it's positive 1. All right, so bring down the 2 here. You multiply by 2. Sorry, multiply by the negative 2. So negative 2 times 2, that will be negative 4. So here we're going to have negative 4. So we're going to add up here numbers, negative 2, negative 4. That will be negative 6. And then, so negative 2 times negative 6, that would be positive 12. So here, so you have positive 12. So 0 plus 12, that's positive 12. Positive 12 times negative 2. So it's negative 24. 1 plus negative 24, that will be negative 23. So actually the answer is, if I'm not mistaken, I guess. So the answer, so the quotient supposed to be, so this is x squared, this is x, here's my constant, and then this is the remainder. Right? So the quotient would be 2x squared minus 6x plus 12. And we are left with negative 23. So I think your answer is about number 2, right? It's not number 1. So anyway, so for number 1, this should be the answer. So final answer should be like, so the 2x cubed minus 2x squared plus 1. Okay, so it's x plus 2 times the 2x squared minus 6x plus 12 minus 23. All right. Anyway, guys, I guess, well, I'm going to stop here. I'm going to solve number 2 next time. All right. And we're going to continue with this same section. So I will see you, I guess, on Wednesday. So I'm going to stop here. Take care and stay safe. All right. Thank you, everyone. And don't forget to vote tomorrow, of course. Thank you, everyone. See you on Wednesday.
Thank you, Professor.
See you next Wednesday. Thanks. Thank you, everyone.